and welcome back to another episode of the C-Suite Cyber Podcast. The C-Suite Cyber Podcast enables C-Suite executives to make security-informed decisions. And today, we have a 10 out of 10 for you. Mike, what are we talking about?
Oh, am I the 10 out of 10? I don't know.
No,
I'll take
not
it.
you.
Yeah, we're going to be talking about the React2Shell vulnerability. That's pretty new. That's on a lot of people's watch lists, a lot of organizations that have React Next applications out there. Pretty bad. So we'll be diving into that, some details that folks need to pay attention to, when it may apply to you, and some other information, really just helping clarify some of that out there. There's a lot of, not necessarily misinformation, but there's a ton. And some of it's applicable, some of it's not. Some things are skipped over in some blogs and well spoken about in others, but we'll dive into that. So before we get into that, let's play catch up, I think, right?
Let's do it.
All right. So what's new?
Filmed a short film pretty recently, so that was pretty cool. Got to vibe code a fake Facebook profile with some messaging capabilities built in there. So, the person sits down, clicks on like Facebook, types a name, it pops up with the profile. She clicks message, it pops up a messenger. She sends the message, and then I have a time configured delay. So after a little bit, it'll like pop back with the response and do the little ding notification and everything. So it was pretty sweet. What about you?
So hang on. Put the brakes on this one. So you vibe coded something for one of the films that you filmed recently? Is that right?
Yeah, it's my film. It's my script, and we produced it over 2 weekends.
Okay, that's kind of cool. I was like, when is AJ going to start getting hired as a consultant on technical films? Because that'd be pretty sick.
Yeah, if only I was like attached to Mr. Robot or something like that, right? But that's obviously over.
Yeah, have a little Easter egg in there for you. There's a bunch of fun little Easter eggs in Mr. Robot.
Yeah.
Yeah. You're a cybersecurity celebrity when you get an Easter egg in a solid show like that. I mean, they won a lot of awards, didn't they?
Yeah, I think so. And I know there's like Occupy the Web. He talks about them a lot with David Bombal on his YouTube channel. So they'll do like what's real out of like the show and kind of recreate some of the attacks. So that was pretty cool to watch.
That is cool. I didn't know people were doing that, but it sounds pretty slick. Cool. What is new for me? What's new? I don't know. Settling into a management role, learning how to keep my hands off of stuff like my mom used to tell me when I was younger, But no, it's pretty cool learning the HR side of things more because I got to lean into that. So that's a lot more fun. In terms of what kind of fun stuff? Oh, we've been doing some fun stuff on the stream. We jumped into Advent of Cyber last week, so I think we'll do a little bit more of that this Thursday as well. So a lot of fun, a lot of really good training out there for folks, and I think they did it this year. Try Hack Me, I guess. Shout out to you, sure. Where you could basically send a link to folks in your company, and so you can kind of track and see what they're doing and kind of work together on stuff. And what's funny is I had someone on my interview today that says they got stuck and watched my video to get unstuck in one of the challenges, someone in an interview. So I was like, okay, cool. Glad I helped.
You'll have to see if you can find them in your analytics or if they're just lying to you, trying to make you feel good.
I mean, they talk specifically about what part I did, and walked in. It's like, okay, cool. You're not just sucking up. Awesome. I have had people suck up, like, oh, I saw your podcast. I've seen your stream, and blah blah blah. But yeah, that's pretty cool. Other than that, just a lot of running. I did, I think, 18 miles last week, trying to get up to this 100K distance. That'll be a good time.
Yeah, I'm trying to get up to 5K, guys.
I think you're just trying to get out the door without being out of breath, but
it's not that bad, dude.
We'll fact check with your significant other. All right, so I guess enough stupid stuff about us. Let's get into perhaps what you came here for besides our charming personalities. You want to kick off? What do you got to give us a little bit of background on what we're going to be talking about?
Yeah, so we are going to be discussing a little thing called React2Shell. So this vulnerability came out end of November, and then it was made public December 4th, it looks like, and then POCs started coming out. And within hours, um, China Nexus state actors were already exploiting the vulnerability and targeting publicly facing applications, websites, etc., which is not unexpected, but it is pretty crazy when you think that this is very similar to Log4Shell, which happened in 2021. So just 4 years apart. I think that one was also a 10 out of 10 CVE score. This one is as well, and it's also an unauthenticated remote code execution vulnerability, uh, which means that you don't have to know any credentials or anything. If it's vulnerable and you send this particular packet, you can potentially execute code. So that's what we're going to dive into. And then from there, we'll extrapolate a few things like some other attacks and similarities to some things that Mike has probably done in the past.
Yeah, so let's take a quick pause, and I want you to talk more about what you just said. So unauthenticated RCE. Why should people care about that more than say some of these other attacks where we see authenticated RCE or requires authentication to do any of this stuff? Why is this so so critical to make sure we pay attention to this as kind of leadership folks?
Yeah, so I think the biggest thing for me right off the back is we tend to place a lot of emphasis on the credentials or the entity, right? So, like, most places are enforcing MFA, you have password complexity requirements or whatever. Maybe you are black holing or restricting your IPs that are able to access certain assets to like your known range. And when it comes to something like this, like there is no authentication. I don't have to know your username, your password. I don't have to have a token that I've stolen from you in an info stealer. I don't have to know anything other than you are publicly facing and you are running this vulnerable version of the app. And to be fair, I don't even have to know that. I can just spray it everywhere I see like React. So you could use something like Shodan or I don't know if Built With shows you that, but Shodan is like a open source intelligence tool or OSINT, and so you can put in specific ports or like specific libraries, tools that these publicly facing assets might be using, and you can see like because it's scanning the entire internet, you can see where they are, and then you could collect a list of IPs and just start spraying these things against them and see what comes back. So it's uh, it's kind of like there you have your house locked, but I can walk through doors, right? Like that doesn't affect me at all. So even if you have good security hygiene, the fact that you are using this tool, React.js, Vercel, etc., I can still enter your domain and steal your secrets or execute code. Um, and there's different attacks that are occurring through this as well, and we'll get into that. But that's my thoughts. What are yours?
Yeah, and just to highlight what you said, talking about it's a house, like having your door locked, like you could have a safe door on your front door, and then you just have a window that's unlocked on the side. And that's kind of the situation we have where, in other cases, it may be like, say you encounter web exploitation and maybe you don't know it's this attack and you're like, okay, they have this account and this is what they're attacking with, and you roll those credentials. Well, it doesn't really matter, right? Because they're just going to get right back in and get the credentials all over again because they didn't actually need to steal them to begin with. They just had them because they were able to exploit, land on your vulnerable web server and do the thing. So that's why this is so serious, because if you don't patch it, if you don't realize you're vulnerable, even if you do catch the web attack in your logging system and with your security tools itself, um, they're going to get right back in until you fix the hole. So it's pretty bad. And like you said, All you have to be is vulnerable. That's all they need to know is that you're vulnerable. And then just exploit, and they're in, and then they can start doing their thing. One other thing I'd hit on with that is you spoke about using Shodan and other things like that. Yeah, absolutely. So this is one of those things we'll see in these widespread 10-10 attacks where yeah, they're just looking for vulnerable stuff, and they're just like they'll get a list of vulnerable web servers and just start hitting them continuously with whatever exploit code they have. We'll talk about how there's a lot of cases where it's not vulnerable or whatever. But yeah, they just go for targets of opportunity. You may not be someone they're specifically targeting because of, you have something they want. You just happen to be vulnerable, and they happen to have code that works for you, and they're going to target you and see what they can get out of it. So yeah, it's pretty serious.
Yeah, I will say too, having developed several things through like vibe coding or using these LLM platforms, right? Like typically when I'm building something with functionality like being able to hit a website or like building a platform that does multiple functions, I'm going to use React and like Node.js. So I'm I would be curious like how many of these vibe coded applications or things are vulnerable to this and how many have been compromised, because that kind of changes the dynamics, as well as no longer are you being targeted because of who you are. You're more targeted because it's it's opportunistic and you're vulnerable. But now, like, people probably don't understand security all that much, are using these tools to develop these things that may make their lives or other people's lives a little bit easier. And then, this could be exploited and could cause you a ton of harm. So I'd be curious what the numbers are on that, if that has been collected anywhere.
Yeah, so I asked ChatGPT what it was, and it says it's take it with a grain of salt, right? I did ask it to give me some stuff, some links to what its reasoning is, but it says potentially 12 million websites are vulnerable. Um, and then there's someone else that did a scan that found 968,000 publicly detectable React slash net.js systems. And then another one says Horizon 3 says 39% of cloud environments contain it. Um, but something else to take with a grain of salt here is that just because they have the vulnerable version of um, React doesn't mean they are specifically vulnerable. I think like Amazon came out and said, yes, they use it. Yes, it looks like it may be vulnerable, but it's not vulnerable the way they've deployed it. So there are some things that are going to be coming up and listed as vulnerable based on versioning, which is how Nessus does a lot of scanning. They just look at the version number and they're going to say, hey, you're vulnerable. But it also just depends on what else is deployed. Like there are specific functionalities that must be enabled in order for you to be vulnerable. So that's just something to keep in mind. Just because you have that version doesn't necessarily mean you're vulnerable to the attack. So the nuances do matter here, and it's worth having a really good conversation with your web app folks, your engineers on this topic for sure.
I just looked the vulnerability up in Shodan by the CVE number, and there's two devices, and one is in Taipei and the other is in Japan. But it showed like in the doc title the CVE number, so I'm trying to see what that actually means.
Are you looking up just the CVE, or are you gonna there? You could look up versioning on there as well and get that.
Yeah, I was gonna do a different query. I was just curious about this.
Oh yeah. So here's the pop quiz question: do you have a paid uh, account for Shodan, or are you a freeloader? There you go.
Yeah, I'm a freeloader.
1 year you got like a lifetime pass, because that's what I have for like something cheap, like 20 or $30 or something dumb.
Oh, okay, so this shows I did not want to go to the website. That's great.
Uh-oh. Go after him,
Um,
police.
it shows, yeah, the doc page. The title is like the CVE number, and it says this server is vulnerable and requires immediate patching. And then it has it in different languages
Hmm.
on that page.
Yeah.
Interesting.
So it's a, I guess to bring circle this back, it's pretty interesting. Um, there's a lot of things that are vulnerable, just like the other vulnerability that you mentioned. Um, yeah, I mean, it's pretty widespread just because of the technology and how broadly it's used, how accessible it is, how kind of open that particular um, ecosystem is itself. Because you said it was what, once owned by Meta and then they released it to Node or something like that?
Not Node. They let it become its own entity, so now it's like the React Foundation, and
Ah,
then similar to the Linux Foundation. And it looks like that occurred in October of this year, which is very interesting. I'm gonna try to send you a link. Do you have Shodan?
I do have Shodan. I have to log into it though.
So this shows 280,589 devices currently. Again, just because it shows does not mean that it is exploitable, but just so we can see, um, while he's trying to pull this up, essentially the query is looking for an X header says powered by, and then we have Next.js, and then we're looking for RSC. And I believe RSC is the key here. I have to remember what RSC. RSC stands for React Server Components. And that is the key piece because without jumping ahead, even if you don't allow server like interaction, that's probably not the right word. I'm trying to find my page. If you have RSC enabled, it can still be exploited.
Under
And
certain
we'll,
circumstances.
yeah,
Because in some cases, depending on how you installed it, it will be available and ready. And in some cases, before this, I was trying to set up a vulnerable system so that I could play with the exploit. So we could, I guess, share some of that here, but didn't have time. What are you going to do? You know, that 9 to 5, baby. But for instance, I did install the vulnerable version of React, but I didn't have the right component in place in order to have what was it, RSC?
yeah.
Yeah, so RSC wasn't when I tried to query and do there's a POC, a certain argument and you send it. It didn't take it because that component wasn't installed. So I had to go back and try to figure out how to get it installed and all that. And then I screwed everything up after I got it installed by accident. So, but that's a case where I installed it. I installed the vulnerable version, but the specific component that was vulnerable wasn't there and wasn't available for me to target. So, again, nuances, right? Let's see. Let me find your link here. I just got Shodan logged in.
One of them is top Forex brokers. That's great.
280,000, so a little bit less on this than before. So he specifically looked for X powered header in the request, and that's what he's searching on in here. And then would you do a string search also for RSC?
Yes.
So it is narrowed a little bit. I'm sure he had even more without the RSC there.
Can you share?
Yeah, let me.
And then we can kind of talk about what Shodan can be used for and
Do we
stuff.
want to share? I don't want to get us in trouble on that one.
Fair.
Probably shouldn't show vulnerable places. Hey, we're trying not to get in trouble here, but we do want to make sure everyone's educated. We
Yeah.
don't want to lose our jobs for this. Yeah, so it is interesting. We do see it in there. It is quite a bit. Let's see where they're all at. There's quite a bit in the US that are showing up in here. The second most is Germany, based on your query here. Actually, no, there we go. U.S., Germany. Yep. Okay. So yeah. Um, Anything else you want to talk about on just kind of that high level overview of things?
Yeah. So just for awareness, right? Like you can create a free Shodan account. You can look up your own infrastructure or your own websites and stuff. Um, Hopefully, if you have a service provider or an MSSP, a managed security service provider, they're doing this as well. There's been times where I've worked in environments that have, dedicated Intel teams that are third party and other third party vendors, and I'll find stuff on Shodan before they do, and it's often overlooked. I think because it is public and it's kind of like, it's whatever, like they have good security hygiene, but you can sometimes find stuff like this, and it's not only one, it's not behind a paywall, and two, it's not something that like you have to be super technical to use. You can just put your domain name in there, and you can see what it shows. And if there is a CVE, if you go to your domain or whatever IP address you put in there, it'll show you on the left hand side like the CVE and what that CVE is for. So there's a little bit of information there that you're able to get without needing, to reach out to anyone in particular.
Yeah, and I'd say too, like, this is like, I think we preach this probably most podcasts where we're like, hey, asset management, like having documentation of your assets, what software is installed, and that's not just a static list. I think a lot of people listen to that suggestion and think, hey, I need to do this once and then I'm good. That never works because almost every day. I mean, think about how many times you update Windows. Okay, that's how many times your versioning is going to change, which is almost every day. Just about, I feel like Windows has an update. Um, and that's how quickly your software versionings are going to be. And the issue with things like this is that it affects very specific versions. So, like this one's like, I think React 19.1. And so you're looking for 19.1.1, and the extra point one means you're not vulnerable. But think about now scaling that, right? We're only talking about a single system in this instance, but now when we scale it, now we're talking about potentially tens of thousands, depending on the size of your organization, and being able to understand what libraries are installed, what types of technology, software packages, etc. And that's really hard to do if you don't automate it. And the reason we want to automate it is because whenever we see something like this, right, come down a 10 out of 10 vulnerability, we want to be able to quickly look up how many systems are vulnerable to this, how many are actually exposed to the internet, what can we do to um, kind of put some things in place to lower the risk that we're going to have a problem, have an incident. And this is where, setting up those automations and then passing some of that off to your SOC folks to say, hey, this is what we've done. We may have an issue. I need you to set up a dashboard or start monitoring these assets to protect us from actually having a big incident so you can react, no pun intended, or maybe it was, to things like this.
Yeah, and you can like if you don't have a list of the known software and stuff, right? Like you could end up, and it doesn't have to be you. You could have whoever's in your IT department or whatever. They can script together PowerShell and run it, and like get a list of the software and stuff like that. So there are things like you don't have to go out and buy um, expensive software, or you don't have to like pay a consulting fee and stuff like this. Like there are things that you can do for free in order to get the information that you need. Um, and if you want help, then you can reach out to us.
Yep. Yeah. The important thing is taking some steps, and you're always going to be able to improve it. There are some things such as your AV. If you have an enterprise AV, you may be able to search that for specific versions of installed software. Packages are a different story, just depending on the language that you're using. They may not show up in a type of scan like that, and you may need um, to set up like a script or something that's going to pull that data for you. But there are security tools that can also do the same thing. The point is to take steps to learn, from events like this that happens, like, hey, this is the thing, I think we're using React, how many systems are vulnerable? If you get the answer of, I don't know, and it takes 2 days to find out, there you go. There's a lessons learned. You probably got popped in 2 days that it was available, and we need to figure out how to reduce that time to maybe a few hours versus a few days. So just, this is where security is an iterative approach to team sport. And we just approach it with, okay, had an issue. What can we do to improve whatever it was that was an issue? For sure.
Yeah, and you mentioned like taking 2 days to get that answer, right? This was exploited within 30 hours
Yeah.
by nation state actors. So like, they're good, but they're also once the POC was released, which the POC came out December 4th, I think the day after it was publicly announced, everyone was able to begin scanning and testing for the vulnerability. So it's one of those things where like you need these processes in place because this will happen again. This is not the first time. This is not the second time. Like it will continue happening.
Yeah, there's also some vendors out there. So if you struggle as an organization, and not to pitch other people's products, I'm not going to say their name or anything, but if you struggle to stay up to date with the latest vulnerabilities, right, that's a whole thing in its own right. In just having a vulnerability scanning team or a vulnerability management team, and all they're doing is scanning, um, you still may be behind the power curve, right? Because they could be, only scanning once a week or whatever it is. But there are specific vendors out there where you put in your technology and then you will be notified when there is a vulnerability that's applicable to you. Again, asset management is key there, but they will release that information to you so you can know sooner than later versus reading something in the news. Maybe you don't give a crap about cybersecurity news when you get off, but at least you have someone watching out for you. And it's tough for smaller businesses for sure, because you got a lot of people wearing hats, a lot of hats, and so you have to find automated ways to do a lot of things, like find this stuff and investigate this stuff, and give you the good feels that you're secure essentially. Man, super corporate-y today. Can we stop? I mean, this is all true though. I mean, this is like we did some preparation to make sure we understood, so we weren't getting any advice. But this is legitimately stuff we've learned and experienced from working in big organizations. I mean, this is real talk.
Yeah.
We'll talk with Mike and AJ. Let's go.
Do you want to start hitting on the uh I don't know, you want to do POCs or like how it works first?
Let's do how it works first, I think. Um, you already went through the timeline, right?
Oh, let me just wrap it up. So
Okay.
on November 29th, it was disclosed to Meta because they previously owned React, and December 3rd, it was disclosed to React with a public disclosure. Within 30 hours, I believe that's the time frame. Like it's around 30 hours. Um, we as in the community saw active exploitation. December 4th, there was a POC that was publicized, which was functioning. So before then, a lot of the POCs weren't actually working. December 5th, the person who identified the 0-day vulnerability disclosed his original POCs, proof of concepts. And then also on the 5th, the CISA or Critical Infrastructure Security Agency, that's what it stands for, added the CVE to the KEV catalog. I don't know what KEV stands for. Known exploited vulnerabilities. That's what it is.
Good job. Didn't even have to Google it today.
So many acronyms in our industry. All right.
There are.
So originally found on the 29th, stuff hits the fan December 4th, December 5th. And let's clarify something because this has come up in another podcast of ours as well. Um, so the POC was made public, right? There are pros and cons to making things public. This was already being exploited, apparently, according to Claude. I'll have to fact check that. before the 4th. So I don't know exactly how that is, but um, it's not uncommon for researchers to find something that is being exploited by some very sophisticated threat actors. And if that is the case, if you make it publicly known, then everyone has a chance to protect themselves or at least identify the activity. That is the pro. The con is you now made it public for low sophisticated threat actors to start scanning and mass exploiting. That is the con. Either way, it is being exploited. If you are vulnerable, you do need to update. And my app, for example, like I checked if I was vulnerable and I was on an older version of like 18. So it's like, no, you don't have to update because you're not vulnerable. Or you can do like a major version update to the next, I think it was like 18 to 19 or something, to like a patched version and do that. And I was like, oh, I'll stay. Like, I'll wait for now.
I think 18 is vulnerable.
What am I on? Maybe it just lied to me. Maybe Claude Code is like trying to get me popped. 18.3.1.
Let's see. I have some notes on like what's vulnerable. Um, let's see. No, it's just 19 right now. Okay. I thought
Yeah,
other versions were because I was working off of 18 and it was supposed to be, I think it was 18 that was supposed to be vulnerable, but
yeah.
whatever.
So I could go from 18.3 to 19.2 and basically skip the 19.1s or 19.01, whatever the vulnerable version was.
There's 19.0.0, 19.1.0, 19.1.1, 19.2. Oh, that's specifically React Server DOM Webpack. Let's see. So I don't have all the React specific versions in here. I'll have to pull those up in a second. Um, yeah, so that is the great debate of cybersecurity, what you spoke about, where the benefit, yes, you let everyone know, that means they can fix it. But then we start talking about smaller organizations with smaller teams that may not be able to get to it until maybe next month. So now they're in a really tight bind because they don't have the staff to address this. And sometimes, this is the problem with web apps, right? So this is the problem a lot of people don't understand. The problem with websites is if you do an update on the underlying technology, you may be completely screwing your code that rides on top of it. And so it's not as always easy. It's not as easy as just saying, hey, update it. It's update it, now see what broke, and ensure everything's working correctly before you go live. So there are some nuances to web applications themselves. Like other types of software, I would say it's pretty straightforward where, there's a vulnerable version of Microsoft Word. Okay, great, update it. But it doesn't work for web applications in that way. And it's the same reason why when we see browser exploitation, right? I don't know if we've seen a ton of that lately, but it used to be a thing where they would check for the specific version of the JavaScript engine, and then they would run specific code for that engine because versions matter to the exploit. That's how precise it needs to be. And whenever I run specific exploits for Windows that may do stuff like at the architecture level, like at the CPU, where you're doing like buffer overflows and things like that, the the version of Windows matters because it's changing all the offsets, at the low level that you need to take advantage of in order to run your exploit. So versions matter all over the place. And that's why versions matters here. That's why we keep saying specific versions. It does matter. And I think there's some misunderstandings with that. I'll get off my soapbox now. Did
Yeah.
you know all that? Did you know that versions affected that type of stuff? Well, some of it.
Yeah. I mean, mostly like server versus an endpoint operating system, like that's where I would see that most, as you know. But yeah,
Have you ever done a thing like old school volatility where you pulled RAM and then you had to analyze the RAM with volatility? You had to recalculate your offsets for specifically for your version in order to pull information because of that.
no. And you know this because you did that when we wrote something.
Oh,
You pulled the offsets file and made that.
oh, gotcha. Yeah, that one. Well, that
Yeah.
wasn't memory. That was like running an
No.
exploit, a kernel level exploit.
Yeah, yeah.
Yeah, yeah,
But
yeah.
no, dude. And volatility, I haven't used volatility ever. I don't think. I used what was it called before or after? It was something else. Responder?
No, that's different.
Is it?
Redline? I think Redline is kind of similar, but maybe you use that.
Are you sure volatility and responder aren't the same?
Responder is a man in the middle tool for offensive security. I know. I use Responder every time on a pen test because it's an easy win and I can get some password hashes pretty quick. Works 99% of the time, folks out there.
You right.
I
The
know
hell
I'm
am I?
right.
Oh, autopsy.
Autopsy. Well, that's different too. Can you pull memory with autopsy? I've never tried.
I thought that was what it was for.
Well, it's a forensics tool for sure, but it's not specifically for memory. It's for like Windows artifacts and file system analysis. Yeah,
Anyways,
there you go. Down the rabbit hole we go. All right, so what's next here? So let's talk about how the POC works. So here's a fun thing. So this is at the root of this is a deserialization flaw. So can you explain in as few words as possible what deserialization is without Googling it?
I hate you. Okay. So this may be completely wrong. To me, it's similar to a SQL injection in that, like, the user is submitting input, and then that input is being read and actioned on by the front end, and then passes it to the back end. So that's how, like, I
Hmm.
visualize it. Um, I know that essentially it takes like is it a blob, or I think it's called a blob, um, and then like deserializes it, so it like breaks it down into components, and then there's the $B is like the constructor, and that is like what's passing it to the back end. I think could be completely wrong, but Mike knows this, and he will explain what the POCs are, or what the actual attack is doing.
Uh, yeah, I mean, conceptually, I would say you're pretty close, right? Where serialization is a pretty much a way of encoding information for the application, and so deserialization is a way of essentially decoding that so that it can read and understand it. And so there's a flaw here when it's decoding, it is potentially executing some of that information in that serialization form. So in the exploit we see, um, there's a point where as part of that data that's being like encoded, when it's unraveling that, it's executing it, and it can be anything, right? So this is where that RCE piece comes in, where it's saying, "Hey, execute who am I?" Right? The classic, did this work? And so that's where it's happening. Essentially, we're giving it data, like AJ said, and then it's processing that data in I don't want to say uncontrolled, but how about in an unintentional way? And then it is executing it because they are now writing that error in the way it's logically handling that data, and boom, we have magic. We have an exploit that is now successful. All right,
Um,
repeat back to me. What did I just say? No, I'm kidding. Um,
no, I'm looking it up. Like the flight thing is what I didn't know. Um, so Claude gave me a handy dandy analogy. I don't know that I like it per se.
all right, what's Claude's analogy?
Um,
Let's hear it.
So their analogy is like serialization is packing a suitcase for travel, and deserialization is unpacking. But the example they give is like, it looks like it's JSON, right? So like, how you can have name or like the field, so in this case name, and um, semicolon, or no, not semicolon, colon, John, and then like age, which is another field, 30, and you could put them together to be like John, comma 30, and then like name, comma age type of thing.
Yeah, kind of. So like an encoding, almost like how we have to do base 64 so that the web server can understand it and it can pass from one medium to another. That's essentially what I was talking about with the encoding. So same thing, just different way of saying it, packing up in a suitcase. So instead of just balling all your clothes up when you hop on a plane and you go to check in, you hand them that ball. It's in a suitcase, it's nice and tidy. You get it, you open it back up, it's in the same order that you put it in, and so you can use it. So that's pretty much what encoding and compression and all those fancy terms are doing. Here on the screen, I provided what the one of the proof of concepts look like, and so we can see the payload, and we can see it's structured, right? So this is where that deserialization comes in, where it's slowly unraveling the structure. And this here, this console log piece here, is what's being executed. Um, so this is a pretty interesting thing here. So we can adjust this to be whatever. And there's this concept of gadgets, and this is a pretty common thing in not only web applications but also in exploit devin as well. We use like gadgets inside the registers and things like that in order to perform basically you're putting pieces together and you chain them together. They're gadgets. So that's the concept they're using here. But it's yeah, I mean it's pretty cool. I mean it's a very clever thing that they're doing here. So this is Wiz's side. I think this is probably the clearest explanation that I've identified. Clear for me because I've done web app stuff, but maybe not clear for other people. I would definitely suggest asking an adult, or I mean a an engineer that can speak human language to help you with this if you want to know more. But you know the concept isn't how does this thing work. It's more of how do I identify things that are vulnerable? You don't necessarily need to fully understand this as a leader, but we need to be able to identify things that are vulnerable. And you need to be educated enough to ask the right questions to your engineer and to your staff to ensure that you've identified the risk, you've handled the risk, you've protected your organization. That's all. Is there anything else you wanted me to show while I have the screen share up?
Um, is there an example? So like, um, if you scroll back up, it had the POC code, right? But I haven't seen an example of like the actual packets. I thought it was in here at least.
Yeah, the POC is right. Oh, I just saw it right here.
Yeah, like
Nope,
sketch it. Um,
right there.
there. So like this is okay. So you have const, so that's like JavaScript, right? Um,
Mhm.
and then you have this. What would this actually look like? Like if you were looking at your web app logs, would you see um, this giant payload, or would it look like something different?
So it depends, right? So this is the payload, and it's being handled in a variable, in a variable. Yeah, I said that correct. My mouth doesn't want to work today. And so this is actually where we're going to get to like later. So he's kind of segueing into another segment, which is how does this actually surface in our logs in our security stack? So this is a very good question. And I think this is a question that a lot of security teams don't have nailed down. Um, and that's also why I was going to play with it because I haven't seen a good demo of it and I did want to see it in the logs. So my answer is going to be a best guess based off of how I've seen web applications work and what I would expect to see in this case. So this is the payload. So what you would see would be, yes, a blob. And this is more than likely, I believe, in a post request. So a post request is a type of web request. So typically we see that when we're submitting data like in a form, that's a post request. So we'd see the blob of this serialized data. So our code is probably going to serialize this in order to transmit it. Almost like you see a lot of times cookies are serialized as well, or tokens of some sort whenever we're talking to a web application. So those are serialized bits of data as well. And we'd see that sent with all the fields. And what we would generally expect to see is a 200 with a request. That's not always the case when we say, hey, we send something and it's in a good format for the web server. Typically, that's correct. But in this case, with exploits themselves, we don't know if we're expecting the application to error out. So it could provide a different status code because we created an error condition. So it could be any of those, but we do expect to either see an error or a success, or maybe even a page not found, just depending on how the service itself responds to the request, right? So if we were sitting at the network layer looking at web application logs, that's what we would see. Now, on the system side, right, what we would expect to see depends on what type of command was executed. So if we're looking at syslogs, like this is a Linux server, we're looking at syslogs, and they ran who am I, we would expect to see a service related to this React.js or whatever application is running the web service to create a process that says that executes who am I or whatever type of RCE. So this is the remote code execution. So what command did they run on that system? We'd expect to show there. So we'd expect to see the payload in the web application logs, and then on the system logs, we'd expect to see whatever that code execution piece is. So that could be, and this is something else on our list to talk about, this could be that persistence mechanism. It could be communicating back out to a C2 or doing an implant or exfilling data or just conducting reconnaissance. Hey, just give me this information if you worked, what else is here so I can figure out what I want to do next. But this is where we have the initial execution. So we're talking about attacker methodology here. And then they're going to start doing all the other things after initial execution, which is that reconnaissance, persistence, privilege escalation if needed, lateral movement, exfiltration. All those things are going to occur after this exploit is run successfully. How do you feel about that?
Cool. So if it was like IIS, for example, on Windows, you would see like IIS as a parent process of like PowerShell or CMD, and then like who am I as the command line of PowerShell or CMD.
Yep. Yep. I would say
So,
that's the most obvious pieces. So the key here, and hopefully someone comes out with it. If not, maybe I can figure it out and I'll put some information out because I'd love to see some blogs from a defensive perspective on how to identify successful exploitation, right? So here's a piece to backtrack a little bit. Say we identified vulnerable systems. Maybe we're 5 days later, right? Or 10 days later, or whatever. How do we determine if a system was successfully exploited? That's the key. And so that's what we're talking about now. We identified a vulnerable system. Now we need to figure out, was it actually successfully exploited? And so, yes, that's where we look for, are these blobs hitting it? That doesn't necessarily tell if it's successful, but when we look at the system logs to see that process create this chain of other processes like running command.exe, who am I, if config, pinging my C2 back, launching suspicious things, that's also what we're looking for after the attack. Because I will tell you, if you have a bunch of web applications out there, even if they're not vulnerable to React or vulnerable to this specific thing, they're going to get hit with it because there are a bunch of attackers out there that don't know or don't even care to ensure that the victim is vulnerable to the attack. They just spray every attack and its mother against every server on the internet. And so what I'm getting at is you can't just rely on seeing this exploit in your logs. That isn't enough to tell you whether or not someone successfully exploited. It just means people are hitting you. And I guarantee if you look, it's going to be everywhere. You need a way to be able to differentiate between a success and well, from failure, just stuff occurring, activity occurring, to actual success, and then progressing their attack chain. What are your thoughts on that? Because you have a lot of insight on the detection side, the discovery of these types of things. What can you help? What type of advice can you lend there?
Yeah, I just added to the Notion page a blog from Asset Note that has some of that. So they're essentially looking for a response code of 500 and the e digest parameter. So typically, what we would do, right, in order to detect this in my environment is we would want to test it against something that we know is vulnerable so that we can get, like Mike is talking about, we can get something that we can then use as a reference point to build off of and to confirm that something is actively being exploited. Because a lot of things, like you mentioned, are going to be actively scanned or they're going to be actively, sent things, but that doesn't mean they're vulnerable. And so not only do you want to avoid like being vulnerable to this attack and stuff, but you also don't want to spend a lot of resources where they're not necessary. So if you are seeing attacks but you're not vulnerable, you don't necessarily need, I mean, you might want to like block it at the WAF or something like that, but you don't necessarily need to spend any more resources on that because there's nothing that they can gain from that, right? They're wasting their time hitting that endpoint. Um, so something like this, the issue here is when we talk about detections, getting into web app detections and such. And so typically, at least in my experience, the visibility is a little bit lower, right? Like it's different than endpoints, which traditionally, have been around forever, and that's where a lot of tools are built. And then you have network, like proxies and firewalls, and so especially if it's HTTPS, like odds are you're not going to see what's actually being sent to your web app unless you're inspecting and breaking, so that you're able to actually see like the content. So if you are not doing that, you're likely not going to actually see this, um, unless you yourself are scanning it and then checking against it to see if it is vulnerable, see what you return with. And so if you see like, okay, here we're looking for a status code 500, and then you can look for anytime my server gives a status code 500 and it contains, um, like about middle of the page here, it says the E and then a squiggly bracket digest, then we know that that is vulnerable. And then you could build a detection off of that. But essentially, you would want to like have something that you know for sure is vulnerable, have a response from that based off of the activity that you're looking for, and then use that response or that output from that test in order to build a detection around.
Yeah. One correction I will make. So you are thinking about it from a certain way, but if depending on the way you're logging on the application, you should see post requests coming in. So you will see the data that the organization or that the adversary is sending because it's going to be decrypted on the application side and logged there. So you should be able to see all of that there, as well as the response codes in the application logs if you're actually getting them in. Even if you're not bringing them into your SIM, which a lot of organizations may not do, you will see, you could go to that server and actually pull the logs, and they should be there if not being overwritten. If you may be talking about if you're sitting in front, like if you have something like a sensor sitting in front of your application, like a WAF or whatever. Yeah, if you're not decrypting, you're not going to see it there. But if you're actually getting the web application logs themselves, you will see it there. So it's just a perspective of what logs you're looking at in that security stack. So I did just want to make that clear because he was talking about one thing, I'm talking about the application logs. So just want to be clear, it is there. You just got to go and look, and you do have to pull them. Again, a lot of organizations aren't collecting application logs because they are very verbose and they do fill up a lot. So it's always a game with the SOC work and the logs you're bringing in. Is it worth me pulling these in, or are they not? Because you're going to have to pay for storage, and you're going to have to pay for probably a year of storage if you have any type of compliance at a minimum. So that is the thing. I do want to go ahead and, since we have this up, kind of talk about what we were talking about with the post request, because I imagine if you haven't had a technical role and you're sitting in the C-suite, you probably have no idea what we're talking about with post request. So I want to show you what it looks like when you click and you send information to a website. This is what it looks like. This is what it looks like to us nerds on the other side, is we see the request. So this is talking about what page is it hitting, what type of request. So this is that post request we were talking about. This is just the version here of HTTP. This is the host name. So this would be like the website you're targeting essentially. And then this is the user agent. It's kind of whatever. It tells you what type of system is sending that information. And then these are all your different headers. And so these are the headers we were talking about: next action, xnext.js. These will look different depending on the application itself. They will change. You will have additional ones. Doesn't really matter. I'm just trying to give you an example of what the request looks like. And down here in the body, this is where we may see a lot of that serialized data go. This is where it's going to show up at. Now, when AJ was discussing that error, this is what he's talking about. So there's things called response codes. So typically when you're interacting with a website, we want to see a 200. That means, okay, we're good. I returned the request. This is normal behavior. It's a 200. With a 500, we're talking about an error. So when I was talking about, it may not be a 200. It could be an error. So apparently it is an error. So based off of the data we were sending to the web server, we created an error condition, which means it sent us a 500 internal server error. So this is pretty good, but I will caution you that there are many other scenarios in which a 500 will be solicited as a status code here. So yes, this is a good indication, and it's going to help you filter some of that noise out, but there will be a lot of other things in there eliciting this. So a lot of other attacks could also elicit this and also be unsuccessful. So it is not a clear indicator that a exploit was successful, but it is one of the indicators for this that it is successful. So for me, I would say we look for a request that looks similar to the payload we're talking about. So serialized payload, we see a 500 return to that. We're going to take that and then we're going to look at the system logs, I would say, like if it's IIS or like a Windows system, we'll look at what processes were created after this, what types of behaviors were occurring. Does it look like it's attacker methodology? Does it look odd? Right? Because we're looking for things that aren't in line with the baseline activity of that server. So if you have someone start executing all kind of stuff and listing directories, that's pretty abnormal for a web server, unless there is an administrator on there actively doing stuff. So that's the type of stuff we want to dig into further. Same with Linux, just different logs that we'll look at, but we can see additional processes. So there you go. Here's a super nerdy look under the hood for folks if you haven't seen this. I haven't seen this yet, so thanks. Thanks, AJ. Good job.
So just to clarify a little bit, the e-digest along in the 500 is what you're looking for, not just a 500.
Okay, there you go.
And that is
right
from...
Here. There you go.
Yeah. Trying to see when this is returned. So that is returned um, through this payload, so that it should be like every time this is executed, you'll see that e-digest, and it's used to prevent sensitive data being returned. It is supposedly highly reliable for detecting this. Trying to see what the number is. I think it has to do with the chunks that it's doing.
I will also say that depending on the logs and where you're looking at, again, this may not appear. I've seen a lot of logs that are on in organizations that it's just this stuff here. You're not actually getting what was returned back to the requester, the person, the user doing the request. So yeah, I mean, I would expect this to show up on the server side and not the network side. But good point. So this is what he's talking about here. This line, we're looking for e-digest. And I'll make sure, I think he has this in our notes. I'll make sure to share this in our description for the podcast so you can go back. Feel free to share this information with your engineers, with your web application devs, all that kind of stuff. That way you can take some steps forward. And actually, we'll try to get this podcast out sooner than later. So I may try to get it out. I might try to get it out tonight. We'll see. As soon as we're done with it, I might try to go live with it just so we can get it out since it's a critical vulnerability.
Yeah, so the scanners, it looks like the scanners are using that e-digest serialization in the response to determine whether or not the asset is vulnerable.
Hmm. Yeah, I didn't want to give an opinion because I haven't read the full exploit here. So exploits are so specific. So, I try to give a high level one here. Um, so good stuff, you know. It always pays to have good offensive people. Like this is a good case where it's always great to have an offensive person you can tap and say, hey, what does this mean to us? Can you test it on something? What if I spin you up like a replica of our system that we think is vulnerable? Can you mimic this so we can see what to do so we can take those logs, give it to our defenders in the SOC, give it to our defense or our detection engineers so they can build out stuff for this? Um, Great example. Great example here. And another case too, where like when me and you would work together, we would do variations. So we could see what stays the same, what's different, and kind of do that whole Venn diagram and focus on the stuff in the center where everything overlaps. That's consistent. And that's what we would detect on. That's what we would discuss when we talk to other teams. So what else? What else on this topic, man? Go ahead and stop sharing.
I didn't think it was very interesting. I posted it in the chat, not in the page, but um, log4j is also deserialization of another string. So when you're looking at these, it looks very similar. Um, I thought that was interesting. I'm curious, like how that individual found this vulnerability and whether or not it was through using assistants through LLMs or if he just happened to stumble upon something and found it. But the actual like deserialization strings look very similar to each other.
Well, what's fun is I will tell you, I never finished the course and I'm sad because I got kind of carried away with Tandem and I didn't have time to finish. But OSED, and that was Offensive Security Exploit Dev course. Oh, it was, well, is it OSED? It was the web one, OSWE, I think is what it was, where you would do, and I've never approached web app security in this way where it's usually black box, but you would get it, you would look for vulnerable libraries or vulnerable implementations and functions, and you would actually trace that. So you'd had the ability to debug and follow whatever data you're inputting all the way through the system, and your job was actually develop exploits based off of this. So in this case, maybe they had the code, right? Because it's pretty easy to install this, and they say, okay, I can see an insecure function here, just based off of how the data is being handled on the system. Now let's follow it through the system, see if there's any point where the data object isn't properly handled. And in this case, the serialized data came in and like, oh, it's not actually scanning this or doing a really good job of securely handling this data. Let me see if I can get it to do something funky. Oh, look, I can run Who Am I? Looks like I got a POC. But that's how the course is. Like every lesson is you working with a new application, a new type of code, a new technology stack, and you're having to build an exploit from scratch just by walking through the code, doing functions. I was like, this is cool. This is probably one of the coolest courses I've had the pleasure of like kind of walking through.
That sounds pretty cool.
Yeah, it's pretty sick.
Have you ever done like reverse engineering of a patch?
Kind of. So I took the GXPN, and that was a part of the materials at one point where, hey, we did exploit dev of something, and then we kind of walked through the thing where they do a really bad job of patching, and so you essentially diff the code, and so you can identify where at in the code they did the patch, and you could identify, was it a really good patch or was it a really bad patch? Oh, what if I just slightly modify this because all they're doing is doing a string check or something stupid like that, and boom, I have exploit Thursday, or what, patch Tuesday, exploit Thursday. In some of the cases, and I think with the new kind of implementation of SDLC, software development lifecycle, and a lot more emphasis on security, maybe it's not as easy. But when we run into cases like this, and not saying this is the case right now, but where there's a 10 out of 10 exploit and they're in a hurry to do a fix, they might not be as thorough with the fix, and you may be able to quickly identify a way to bypass whatever fix they did. So I have done it to some degree. I don't do a ton of exploit dev these days, though.
Yeah, that happened with something um, where they deployed a fix and it was like very trash, my words. And there was immediately a new version that came out that was still exploiting everything the same way.
Happens all the time. A lot of those CPU ones that were going on for a while, it was kind of like it was back to back to back to back exploitations. What's it, the Spectre
Yeah,
series? Yeah.
Spectre and Heartbleed, and yeah, that's above my technical capacity for sure. I do not
Yeah.
move, jump, push, or whatever the other thing is.
Well, I don't do that anymore, but yeah, that stuff's wild. Yeah, it's fun though. I'd like to, if I ever could stop working, I would spend a lot of time doing exploit dev. I think it's fun. I think it's cool.
Yeah. Speaking of exploit dev, getting back to this, what are some of the attacks that have been observed in the wild from exploiting this vulnerability?
Yeah, so actually, I want to pull up that page that I had up earlier on this. So, this is something I coach to my guys. So, in case you haven't heard me say 50 times, so I'm a global SOC lead, so I have a ton of people under me. And so I'm the technical lead, and my job is to make sure we are ready to handle any situation and we can adapt to the changing environment. And so one of the things I really coach for people as they're growing as SOC analysts, um, specializing, is looking at stuff collectively on the attack train, because no matter what, who the attacker is, they have to progress through the attack train. So somewhere in there, we're going to be able to catch them, and based off of where we catch them at, we can pretty much identify how they got there. Right? They had to do something to start executing stuff as system admin or whatever, right? So, hey, so we're missing the initial compromise, we're missing the privilege escalation, so we need to look for that. Or they jumped from this system. We caught them when they were doing lateral movement. Okay, so we still need an initial foothold. We need to figure out how they escalated privileges. We need to figure out if there's persistence. So looking at stuff collectively as there is an attacker methodology, a series of steps that an attacker must do in order to progress their attack to whatever their goal is, right? And so when we look at these things, that's kind of where we're at. So he's talking about the end. What happens after exploitation? What are these guys doing? What are we seeing? And this is going to help your guys in the SOC. If we do see successful exploitation, we can kind of utilize, okay, well, what are we seeing them do? Well, if we see a specific payload, we could probably tie it back to another threat group and see what other types of behaviors they typically do. All right, enough of that background out of the way. We're seeing credential grabbing. So this is things like there could be API keys, specific secrets for cloud infrastructure, things like that, database keys, all that could be on the web server itself, and we could see that exfilled off of a system. We could see just general hands-on keyboard stuff. So this is them. This is pretty basic netcat pipe here. And it's just a way to get a shell back so they can interact with the system and do all these other fun things that we were talking about, the lateral movement, the reconnaissance, all that fun stuff.
Hold on, Mike. So if this were to be exploited,
Yeah.
what permissions would they have off the back?
Well, we don't know. It'd be whatever the web server had. So this is a case of if you did a good job of locking down that web server, like in terms of what service it's running as, then you're kind of limited to that. And we're going to have to watch them work through that step of escalating privileges. And so they're going to make a lot more noise when they get on the system. But if it's running on admin, as admin or any type of super privileged account, you're kind of in trouble. That means they can instantly start doing stuff like grabbing all these secrets, dumping the shadow file if it's Linux, maybe grabbing password hashes locally, all those things. So it depends. It depends on how you have it set up. I would say many environments these days are doing a decent job of locking down those service accounts, but some aren't. I mean, there's a thing where you're asking people to do stuff really quickly, like patch and deploy quickly, and they're just trying to get it done. So they're maybe not prioritizing security. I get it. It happens. So this is a fun mystery. We don't know what boat you're in, but you could be in a really bad boat or a only kind of bad boat.
Yeah, I just wanted to highlight it's running as the permissions that the service is running as.
Yeah. He's trying to pop quiz me here because I got him earlier. We also see some crypto miners. We also see some persistent implants. So these are things like their Cobalt Strike is probably a term a lot of people have heard, but it's a way for them to set up control that they can get back into. And so persistence is important because if you didn't do a good job gaining control of the system back, right, kicking the attacker out, even if you've reset your credentials, all these things, they're still there. You didn't get rid of them because they set up a service or something that is going to continuously talk back to them, even if you change the passwords. It's like saying, hey, you changed the key to the door, but you still left the window unlocked to go back to kind of our metaphor at the beginning. Same thing. They went in, like I broke into your house, like I kicked down the door and I went out the window, but you didn't notice I went out the window and left the window unlocked. I'm coming right back in when you turn the lights off. So, yep. Yeah, anything you want to talk about? You like crypto stuff. Do you want to talk about the crypto mining thing?
I like crypto.
You're a crypto guy.
Nah. Yeah, I want to point out too, like the reverse shell and some of these other things, right? Like that means that your device that has been compromised is reaching out to them. So it changes the dynamics a little bit, or at least it can change the dynamics as far as your protections that are in place because you're reaching out to them. So as long as like, your proxy isn't blocking their C2 domain, or hopefully they're not using a direct IP address, but just want to specify that you're reaching out to them so that can change some of the dynamics that are in play there, rather than them coming back into you. So like Mike was saying, if you rotate and all this, or if you now it's a little bit different, right? Like if you just have a reverse shell, if you reboot the system, that shell dies. It's not going to kick back up. But if there is a cron job or something that starts that back up, then you would still be at risk, where you're establishing the connection out to them, and then they can basically run commands as, again, whatever the process, whatever permissions that process has. A lot of this stuff too is basic, right? Like this is not specific to this attack. This is common. Typically, you're going to escalate. Typically, you're going to establish persistence so that you have a foothold in the network. And then crypto mining is a little bit niche nowadays, but if that is what your goal is, right, is to like generate revenue, then that's probably how you're going to do it. Unless you're attacking a crypto, what do you call it, broker, like Bybit or something like that. Just saying. Exfiltration to attacker, same thing. Like you're just sending data, so all of that could look pretty similar. The credential dump, that could be done as easily as enumerating like the environment. So if it is Linux or Mac, like if you just look at the .env file, typically people put stuff there. Sometimes people put credentials, which you probably shouldn't do. That can be as simple as like running one command, and then they now have credentials that they can use to move laterally, or potentially escalate as well. Like maybe you have a user who is a little lazy, so they kind of have their password saved somewhere, and it's a different system or a different service than what they normally log in as. So they can just copy paste that in there, or run something as that user by reading those credentials. So if you have cloud infrastructure, typically you'll have like .aws or whatever it might be. And so that's stored in your environment. And if you were to run AWS CLI, it would read the credentials there, authenticate you, and then execute the command.
Yeah, there's a lot of things here that he's talking about that are really good. I would say the key here with persistence too. A lot of people don't think about persistence when you learn in the offensive world is to be able to survive reboot and to be able to survive a lot of stuff. You want to stay on the system because you worked hard to get there. And so even if you patch this thing, if you do persistence right, they didn't kick you out. You're still there. You'd have to completely either find it or blow the system away and create a new one to get rid of me. And there could be other things to talk about, other types of credentials that may be in here besides just passwords themselves. You could have SSH keys. You could have a connection between one host to another in the web service, one web server to another. A lot of times we have micro architecture where there's a lot of individual components to a web application. So you may see a connection there, especially the databases going back. And even in the main web application, a lot of times you don't see it as much anymore, but you'll see database credentials stored in the configuration file. Hopefully those are encrypted. They could take them and crack those as well. And even, I would say less likely so, but there could be Kerberos credentials, so tickets stored on the system as well that they could leverage to go to other systems. Hopefully that's not the case if they set up their web servers and isolated them appropriately.
I am surprised that for the persistence side, they focused on Linux related things. I guess, well, not too surprised. I run stuff on Windows sometimes, like when I'm not on my MacBook, right? But I guess typically you would be running on a Linux or some distro of Linux for web apps.
Mm-hmm. Yep, it's free.
Yeah.
Yeah,
Yeah.
typically you'll see a lot of like IIS stuff on Windows, but a lot of other stuff you're going to see running on Linux. Yeah, fun stuff. All right, so I think we've pretty much hit everything that we wanted to hit in this episode, I believe. Yeah, and we did the last point already because we talked to that early. You gave us a nice segue and we hit it early. So I guess let's go ahead and do a recap, and then we'll close this bad boy out. So talk about everything, give me another definition for serialization. Uh, just kidding. But go ahead and wrap us up and bring us home, man.
Yeah. So thanks for your time. In this episode, we discussed the React2Shell vulnerability that recently came out, a couple of ways that you may be able to identify the attack within your logs, what it actually takes to execute the vulnerability, and just some general context around other web app attacks and what the downstream effects of this could be. So just because you are vulnerable or you're running a vulnerable version may not mean that you're vulnerable. And even if you are, doesn't mean that it's able to be exploited easily or at all. Another thing to note that we kind of brushed past is we only know the numbers for publicly facing assets. So it's very possible that once someone gets into a network through, say, exploiting this vulnerability, and they scan across other devices, there could be potentially more numbers out there that aren't reported. So as always, check your own assets, have a good asset inventory, asset management, software inventory. That is key as we seem to be moving more and more to packages or library types of attacks, especially with the last two big attacks that have occurred across the web. So, as always, if you have any questions, you can reach out to us at tandemcybersolutions.com. You can email us at csuitecyberpodcast@gmail.com. Occasionally, I read those emails. Occasionally, I forget it exists. And Mike, anything else?
No, make sure if you enjoy our podcast, make sure to follow or subscribe. We're definitely pretty consistent with our content. Give us some feedback if there's something you'd like us to explain for you to help you make better decisions, more strategic decisions. Let us know. We're happy to help out. Other than that, I would say have a good one. Best of luck with this. Hopefully, we provided some help.
Yeah, and we will include our links in the show notes so you can open those for yourselves and get a little bit more information there, as we are not experts and we do not contribute to any blogs because we have other jobs to do. Thanks.
Thanks. Bye.